I would like to introduce the speakers for today's webinar, Using AWS WAF and Lambda for Automatic Protection. Our first presenter is Nathan Dye. Nathan is the Software Development Manager for AWS WAF. He has been with AWS since 2010, where he's led several software development teams for both Amazon CloudFront, AWS's Content Delivery Network, and Amazon Route 53, AWS's DNS service. Our guest speaker for today is Glycon Moraes. Glycon is the infrastructure manager for Magazine Luiza, one of the largest retail chains in Brazil, with 736 stores, 8 distribution centers, and over 24,000 employees. Glycon oversees all of his company's infrastructure within AWS. Our subject matter experts answering Q&A throughout the presentation include Nihar Bihani, who is the Principal Product Manager from Amazon CloudFront, and Brian Barker, one of our software development engineers for AWS WAF. And with that, we will now kick off today's presentation, and I'll pass the mic to Nathan.
Thanks, Nicole. So today's presentation is 300 level, and I make some assumptions that you have already a little bit of working knowledge about how AWS WAF works, familiarity with networking, and even some scripting and coding. We'll review some code samples today throughout our demos, but most of this content in the webinar can be used without expert level code background. I have 2 goals for this presentation today. The first is to make it easier for you to set up AWS WAF with automated protection. The second is to provide you with tools and open source software that you can adapt and approve for use in your own environments. And I actually hope that if you do find new and innovative ways to improve those protections, that you share it back with the AWS community through the WAF forums or through our GitHub lab site. Most of our presentation today is made up of demonstrations and walkthrough that will show off AWS WAF plus Lambda protections. Then Glycon's going to talk about how he used some of these protections, particularly the HTTP flood protection, to protect his e-commerce website prior to Black Friday. And at the end of this presentation, we'll share links to tutorial sites that provide walkthroughs of the protections you see today, and you'll have access to links to the AWS Labs GitHub site. So if you've operated a website on the internet for any period of time, then you know there are a whole lot of bad requests flying around. And website operators need tools to help them find and block bad requests. Those bad requests can be anything from specially crafted requests designed to exploit vulnerabilities in your web application, or volumetric attacks designed to take down your website, or bots that are just out there to scrape all of your content and post it somewhere else. AWS WAF provides you with visibility tools to see what kinds of requests are hitting your website, and a flexible rule language that allows you to block bad requests. The demonstrations today highlight the customizability of AWS WAF provided by its full-featured APIs. And each of our demos feature the use of Lambda, a scripting environment that allows you to develop and operate your own automation without having to manage server infrastructure. By combining AWS WAF and AWS Lambda together, you can create automation to improve the security of your website. So a traditional security model tends to make heavy use of set and forget rules. Now these rules are a really effective mitigation technique, but static rules don't always keep up with the shifting pattern of attackers. For example, scraper bots are notoriously persistent, and they constantly vary their request to evade those static scripts or static rules. Automation can detect and adapt to those shifting patterns. And not only that, but we're finding that more and more customers need to integrate data from other parts of their application to improve their security response. For example, customers in the financial services industry may pair weblog data with banking transaction data to identify fraudulent activity and block bad actors right at the front of their website. I've had a chance to learn about a number of customer security architectures, as well as many security systems developed for Amazon Web Properties. And I've noticed a common architectural pattern over and over again, and it looks a lot like this. So right at the front of the web application stack, there tends to be a layer that is the first point of contact for any external request. That layer usually has some kind of blocking capability, either the ability to filter requests based on source IP address, or maybe string matching by looking inside of the web requests themselves. That layer also has the ability to log and track all of the traffic data and produces a bunch of rich logs that are then stored for days, weeks, or months at a time. That's then paired with threat analysis software that goes through all that log data looking for good behavior patterns and bad behavior patterns. And when those bad behavior patterns are identified, there's a system that completes the loop and publishes block lists back to that very front end piece. Now, in a traditional data center, this kind of infrastructure can be challenging to set up. So lots of traffic volume coming from that front end means a whole lot of log data that has to be stored somewhere. And now that you have all the logs stored, then you need lots of computers running around that can ingest all that log data and process it. Once you've identified the bad patterns, you need APIs on your blocking layer that make it easy to update blacklists. And finally, when those block lists are in place, you need infrastructure that can scale when the bad guys decide to turn up the request volume. In AWS, it gets a bit easier. So in the demos you'll see today, we'll make use of S3 to store all of the log data, which means we're not going to run out of space. And then on the back end, we'll make use of Lambda so that we can do that log processing and detect bad behavior without having to manage any server infrastructure. Finally, you'll see the AWS WAF APIs make it pretty easy to update your block lists when you find bad patterns. And because AWS WAF is running on CloudFront, you know it's backed with the scale that's necessary in case the bad guys do decide to turn up the traffic volume. AWS WAF connects seamlessly with the whole AWS ecosystem. You'll also see in our demos today use of CloudWatch. The AWS WAF publishes its own CloudWatch metrics for visibility. Some of the protections that we're demoing actually add some additional custom metrics to give you even more visibility into what's going on inside the protection services. The 4 protections you see address 4 really common web security use cases. The first protection is a tool that synchronizes your AWS WAF rules with open source third-party reputation lists. The second automation is designed to detect HTTP floods by analyzing CloudFront logs. The third protection uses a similar technique. It analyzes CloudFront access logs, but instead of just counting up the requests, it does a little bit of additional analysis and search for bad requests for 400 series error codes and uses that to instruct the blocking procedures. The fourth and final protection finds and blocks bad bots that aren't respecting robot.txt instructions. Now each of these demos can be used standalone. It's easy to set up with CloudFormation scripts, or you can use the source code as a reference implementation for your own custom implementations. So our first protection is IP reputation lists. Organizations like Spamhaus collect data on known sources of spam and malware networks, and they make those lists available to anybody that wants to use them. Tor is another example of a good source for signal in a web security infrastructure. So Tor nodes are web proxies that anonymize the requester. And these proxies are sometimes used by malicious users to probe websites or send malicious payloads. You can use the Tor endpoint node list as in your web application firewall to either just monitor any traffic coming from these Tor nodes, or if you'd so choose, you can block it. This particular protection has a couple of useful bits of code that work for anybody that's building automation that's working with large IP network lists and AWS WAF IP sets. In particular, it includes some logic that can map any arbitrary CIDR range or network range to the network ranges that WAF IP sets support. In addition, there's logic in there that can take really large input network lists and split them across multiple AWS WAF IP sets in order to stay within the 1,000 IP CIDR per IP set limit. So this is an overview of the architecture and how this protection fits into the overall picture. So at the front end, we have our website fronted with CloudFront, and you can see that we have Elastic Load Balancer, web servers, and a database backend. The area in gray is the bit that's set up and configured for the CloudFormation template. The CloudFormation template will configure AWS WAF with rules and IP sets to receive the processed reputation list IPs. It will also set up a Lambda script that on initial deployment will call out to a set of third-party reputation lists. We'll go through the process of mapping their CIDR ranges to the WAF CIDR ranges, splitting them across IP sets, and then pushing them into AWS WAF. And then we'll also see how we can use CloudWatch to schedule a recurring event to trigger that Lambda function and keep those lists in sync as they change over time. So let's take a look at that script in action. With that, we'll go over to our screen share. All right, so first up, I'll show you, give you a sense for what the reputation lists look like. I mentioned the Tor node list, so if you go to torproject.org, they maintain a list and publish a list of all of the exit nodes that exist. And you can see that we have exit address and a list of an IP address right here. So the Lambda script today is capable of ingesting this list and turning it into that AWS WAF IP set. Here's a different example. Here's one of the drop lists published by Spamhaus, and this one in particular, I'll call out that I'll use this as the example to demonstrate how the script can map from these arbitrary CIDR ranges to the CIDR ranges the WAF supports. So in this case, we've got a /19, which needs to be mapped down to a number of /24s. And here's an example of a /24, and this can be imported directly into the AWS WAF IP set. All right. So I'll take you into CloudFormation. I've already run the CloudFormation template to set up this particular protection, and it is set up right here. I named it the rep list demo. And what I want to show you in particular, when this script runs, it generates an output. And this snippet of JSON is the input to the Lambda script. It contains a list of all of the IP reputation list sources, the URLs that you can call to. And it contains a list of the AWS WAF IP sets that you want the script to synchronize with. So in this case, I have 2 IP sets. Okay, the CloudFormation template for this protection also set up 2 IP sets for us. Okay, we have the rep list set number 1 and reps list set number 2, and you'll note that there's nothing in there right now. So if I go over to my Lambda function now, we've got our reputation list demo here. And I can fire off this script right from within the Lambda console. So if I hit save and test, we'll get an output within the Lambda console of the log data. So you'll see that this list was large enough, this particular Spamhaus list was large enough that we split across 2 IP sets. We filled all of IP set 1 and even overflowed and did 69 CIDR entries into IP set number 2. So now if we come back to our WAF console, we'll see that the IP set is fully populated, and all of the network ranges from that reputation list have been mapped to the /24s or /16 that AWS WAF supports. And if I delete a couple of these guys can rerun the script. The script's going to check for the differences, and it will resynchronize. And you can see right here on this log line, it detected that IPset2 required 3 updates, and it re-added the networks that I had deleted manually in the console. All right, with that, we'll go back to our presentation. So sometimes the bad guys just want to take a site down. And for our second protection, we've developed a system that can detect HTTP floods and deploy automatic blast list updates to guard against this. Now, these HTTP floods typically make use of well-formed web requests designed to overwhelm a server. They may target expensive parts of your website, like search engines that make heavy use of a back-end database. And in fact, sometimes relatively low rates, as much as like 10 requests per second, can have a big impact on server utilization. HTTP flood protection scripts leverage CloudFront access logs to identify source IP addresses sending abnormally high request rates, and then adds them to a blacklist. Let's flip back over to our screen share. Okay, so for rate-based blacklisting, I'll show you, for the rate-based blacklisting demo, I'll start from the CloudFormation template so you get a sense for how that works. I've opened up the AWS Labs WAF samples where all of these protections are listed. And if I drill into the reactive blacklist, we've got a WAF template.json file here. I'm going to grab this and head over to the CloudFormation console. And I'll set up the template. If you do a quick refresh here, you can see that the template shows you all of the resources that the script will configure for us. Now I'll launch the template, and it'll step us through a wizard to configure Lambda and S3 in order to make the HTTP reputation list work. So I'll name my stack. In this example, I already have a CloudFront distribution set up and configured to forward access logs to an S3 bucket. So I'm not going to have the script create an S3 bucket for me. My bucket name is RBB-demo. And these parameters are specific to the protection itself. So this request threshold is the main feature of the script. This value here says it'll find any IP addresses that send more than 400 requests in a 1-minute period. And if that IP address does that, then it will be added to a blacklist for a period of 2 hours before it's removed. Get this set up. Okay, click through and acknowledge, and if I hit create, it takes about 5 minutes to set up. And what you end up with is another CloudFormation stack like this one. We have our rate-based blacklist demo. And you can see all of the resources again it created. We've got 3 different conditions, IP sets, that will be updated whenever the Lambda script processes the CloudFront access log. And I'll show you what that CloudFront access log looks like. So this is a sample access log that I'll use for the demo. This is the format that CloudFront produces. You can see right at the beginning of the log file, we've got date and time, as well as the edge location that sourced the attack. This script primarily is looking at that date and time and the IP address to identify the high request rates. All right. With that, I will pop over to S3. The script itself also keeps a little bit of state in the S3 bucket that you configure in this JSON file. It'll track all the IP addresses it's blocked and then have details about how long it's been blocked for. And here is where I will upload our sample access log file. Okay. So we'll start our upload, and what we expect to see is this auto block set will get updated with the IP addresses that have exceeded that 400 requests in a minute threshold. Let's just take a look and see if our okay, there we go. So the script finished executing. In my testing, it takes about almost 30 seconds to process that sample log file. And now our WAF list has been updated with the set of IP addresses that we want to blacklist. Okay. With that, we'll go back to our presentation and go on to the next protection. All right, so the flood protection is great for those bad actors that are sending well-formed requests, but bad actors aren't always sending well-formed requests. They may instead probe for known vulnerabilities, whether or not your site is even using those vulnerable frameworks. A really common example is the WordPress pingback exploit. Bad guys are constantly probing websites for this vulnerability, and it's often hitting websites that aren't even running WordPress. And the result is that the web server will send back an error code, like show up in your access log and serve as a really good signal for malicious intent. So this third protection uses a really similar technique to the HTTP probe in that we are looking at HTTP access logs. But we're going to do a little bit of extra log analysis to find those bad requests. All right, I'll show you. And we'll flip back to the demos. And in this case, I won't do a full walkthrough of every component of the request, but I do want to zero in and look at the code itself to show you the really interesting bit. So if we go to our Lambda function, we've got our bad request rate demo here. So this particular constant, this block error codes, is one of the magic parameters. So this is the part of the code that lets you configure which error codes you want to zero in on and use for your threshold-based inspections. If we go a little further down into the software, we'll see where that constant is referenced in the analysis. So this is the portion of the script that's going through each log line of the CloudFront access log. And if that log line matches the error codes that are specified further up, and it's going to log the source IP address and date and time and incorporate that into the threshold-based analysis. Now, I think what's really interesting here is that this by itself is actually a really useful protection, but there's a potential for a whole lot more. For instance, we've heard from a number of AWS customers that are concerned about data exfiltration, and so they have set up automation that's actually looking for the amount of data transferred back out, and they're using that as the main signal for anomalies. And if they ever see a really large amount of data going to one given IP address, that may be a sign that something's bad is happening and cause the security team to get engaged. Additionally, you don't just have to operate on the source IP address. The CloudFront access log provides a lot of rich information that can be used to identify some source of an attack. In particular, the user agent field and the refer field are common HTTP headers that sometimes show some interesting signal and filterable signals when bad stuff is happening. And the AWS WAF is capable of creating block rules or count rules based on those header values. All right, we'll go back to the presentation. So our fourth and final demonstration is designed to detect robots that aren't doing what they're supposed to be doing. Now I'll start by saying that there are a lot of bots out there that are very good for website operators. All of the major search engines rely on them to discover websites and index web pages so your customers can find your content. But not all bots are well behaved. Sometimes they consume too many resources or willfully ignore the instructions you're providing to them. And with this fourth and final protection, you can find those misbehaving bots and either block or just monitor their activity so you know how many of your resources they're consuming. The architecture is very similar to the protections we've already demonstrated. So right up front, we have Amazon CloudFront paired with AWS WAF. The big difference with this script is that instead of using CloudFront access logs as the source of information and to find those bad bots, this protection leverages Amazon's API gateway to extend the website with a Lambda hook that ends up being providing a much faster response time than the log analysis-based approach. So our CloudFormation template will set up the Lambda script, and we provide some examples to get you set up with this Amazon API gateway. And I'll walk you through those components. We'll flip back over to our screen share. Okay. I'm going to show you a demonstration website that was created to highlight some of the features of AWS WAF. So the way this protection works is we're effectively creating a trap for misbehaving bots. And it starts with the /robots.txt file that exists at the root of the website. This particular one has instructions that say, don't index this URI or this honeypot URI. Now in practice, when you're implementing it, you probably wouldn't want to name it as something as obvious as honeypot because you don't want to signal to the bad bots that you've created a trap for them. So in addition to the instructions, you also need to hide links in your website that the bot will find and attempt to index. So here's an example of what that looks like. So with these two components on your website, the trap is set. But now we need a way to detect when a bot hits this website URL. And that's where API Gateway comes in. If we flip back over to API Gateway, I have a gateway already configured using the setup instructions available in GitHub. We've got our /honeypot URI, and we've got two verbs configured, a get and a post. You'll see if I click on this, our API gateway is configured to immediately forward request details to a Lambda script, which in this case is named badbot_demo. This Lambda script takes the information from API gateway, it parses out the IP address, and then it updates my AWS WAF IP set to block any future accesses for that IP. And now that we have our API gateway set up, we also need to configure CloudFront to make use of that API gateway. Okay. Here we go. We'll drill in here. So I've already set up this distribution. I have it configured with all of my content in this case is coming from an S3 origin. But I've also configured this separate origin, which points to my API gateway. With the origin configured in CloudFront, I can now set up a cache behavior so that any request that comes to my CloudFront distribution on /honeypot gets forwarded to that custom origin. Now all the plumbing is set up so that whenever anything hits that honeypot, it's going to go through API Gateway and trigger the Lambda function and then update my AWS WAF. And now, in the end, if we browse to the /honeypot directory, we get blocked. And now, once the AWS WAF is updated, we get blocked whenever we try to access the main website. All right, let's go back to the presentation. And with that, I'll hand the webinar over to Glaycolm, who's going to walk you through how they use the HTTP flood protection to keep their site up and running through Black Friday.
Thanks, Nate, for the introduction. As Nate mentioned, my name is Glaycolm Moraes, and I'm the Infrastructure and Architecture Manager for Magazine Luiza. Handle a lot of the day-to-day operations with our architecture at AWS, as well as our initiatives with big data. Magazine Luiza is one of the top 3 e-commerce retail chains in Brazil. We have 700 physical stores, we employ about 24,000 people, and we have 8 distribution centers across the country. You can think of us as like Amazon.com, but with a dedicated focus to the Brazilian market. At our e-commerce platform, during a normal day, our site sees around 4 million page views. In contrast, during the Black Friday, we saw 28 million page views. About 2 years ago, we made a decision to go all in with AWS by leaving our data centers and moving our backend servers, web application front-end servers, and content delivery to AWS. But instead of just porting over the application to cloud, we also started breaking up some of our monolithic applications to smaller applications based on Python to take advantage of the scale and architecture of AWS. So as part of this transition to AWS, we are leveraging a lot of security features that the service offers. With our site being a commerce site, we see a lot of bots and scrappers that can affect our availability and put a strain on our resources. With every new security feature we add to protect our site, we have to balance those against performance too, so we cannot just block or make the requests slow. So during the process of improving our security, we looked at transactional WAFs, but found that they didn't work for us for 3 main reasons. So traditional WAFs, they come with inflated models. So by inflated models, I mean that WAF, they come with preloaded rules and application behaviors that are application specific. So in the end, we found that those rules, they either didn't work for us because they were for applications that we didn't use because we built our platform, or they would yield a lot of false positives for us that would be very hard to manage. Second reason was scale. So the more things we did with a traditional WAF, the more it would cost in CPU. So traditional WAFs, they are boxes or virtualized software. So they are very hard to scale horizontally. So if you wanted to connect some of these boxes to our log analytics, that would have a spike, CPU spike, that would be hard to handle to us. So if we were aggressive with the features, we found out that this would have an impact on performance, which ultimately affected the shopping experience too. The third reason was automation. Well, although we are a big e-commerce, we are a very small shop. We have a very small team, and we want to keep at it. We invest a lot of time and effort on automation. So we want to automate our security response with log storage analysis and role updates using APIs and all the skills that we acquired programming. So just like Nate showed in the previous slide, we have to purchase a server. If we wanted to store the logs, we have to purchase a server that would have to be like S3. It's hard. We are leaving the data center, so it would be hard to have this kind of servers around. And a practical example of WAF usage is some of bots were throttling, were making our search scale up, and we were spending a lot of money trying to answer to all those search requests. we found out that these were both scanning our catalog. And search response time is very important to conversion rates. You can lose a customer if you take too long to answer a search request. So these were things very complicated to deal with traditional hardware. And to make things even more complicated, we were getting near Black Friday, where we anticipated like a 30% traffic spike in the worst case scenario. So in September last year, because we come up with this whole solution, this is how we look at AWS. We were already using CloudFront to distribute static content and assets, and a fleet of EC2 servers running Varnish to handle our navigation and security before requests hit our web application. A user would come in, navigating around using Varnish, we manage it, and requests for static contents were served directly by CloudFront. So we had a burden to manage a cluster of Varnish server. The problem with this architecture is that this cluster was becoming a big problem to manage. We have configuration rules, we have business rules, we have regions rules, but as the traffic grew, we had to duplicate each configuration in all regions. That required a lot of development in the application side to cope with these limitations too. Additionally, even though AWS had 11 regions where we could host our Varnish servers, it didn't compare to the reach of CloudFront. We had 53 edge locations. And again, in terms of e-commerce, the latency is very important, so we could not count on having our Varnish servers in Japan or any other data center from AWS. We needed delivery near Brazil. So when WAF was released in October, we saw this type of functionality already built in, and we decided to make some changes that would allow us to scale and build better security. So we changed to this is how our application was, and we changed to how our architecture is right now. So to be able to use WAF, we moved all traffic to CloudFront, both static and dynamic. With this new architecture, we distributed the business rules that were stored on Varnish in different layers. So all navigation came through CloudFront, so the heavier rules, the redirect and SEO rules, they stopped there. These allowed us to scale much better, increase performance for both types of content, and simplify our architecture because it took out an operational burden out of us. We were able to turn off the Varnish servers, and in our application, we're responsible only to deliver traffic and close orders, not manage SEO requests. The second thing that we did was to move our security rules that were stored on our Varnish servers to AWS WAF. With WAF, we were able to quickly count requests and start identifying which requesters were utilizing our resource the most. This took us some trial and error, and we had to play with the right thresholds, but by using AWS WAF and Lambda, we were able to free up a lot of resources from our web server because the analysis was happening out of band. And all of band analysis is very important for us because we could not just apply a off-the-shelf rule to our website. We needed to be able to analyze our live traffic and apply these rules. And most of these rules, they are allow and deny a block of IP addresses. So to tell a good story, I wanted to share some of the milestones that we had when we moved our architecture over to CloudFront and WAF. But between September and October, by the end of September, really, we had made the decision on what we wanted for our new architecture. And mind you, this is a very small team. Basically, we had one guy looking over the architecture and coming up with both dev and ops sides of what it should be. And then by beginning of October, we start making the changes. And during this time, we are running some component tests, adjusting some of our assets, and by the 1st of November, we have everything in place to move all production traffic. Beginning of November, we started to run specific load tests and then more general load testing to check if we were with the right caching rules and if our matching engine was catching all bad traffic that could be generated. We read from our CloudFront logs and we came up with some traffic patterns to test against the new architecture. So from there we start counting down the days until Black Friday. On the first week of November, we did a full capacity planning meeting with AWS, and our architect helped us to come with which would be the proper capacity for Black Friday. So we asked them to warm up capacity. On November 19, we moved all our production traffic over the new architecture, and this was really easy because on our architecture, we just used the route 53 to move traffic around. So we end up with a blue-green deploy environment, and we did a first traffic change to a blue environment with the old architecture, and then just use a DNS to move traffic around. By the end of the day, and then from that day to November 26, we were doing twice a day checkpoints with our team to check our traffic, to come up with new rules, to manually insert rules. Like we found out that a couple of IPs on Netherlands come up and down on our Lambda log checking as a aggressor running a lot of bots. So I went in manually and blocked these IP addresses. And by November 26, we were ready. We come up with, we were ready to run our Black Friday here. So we jumped from 4 to 28 million views a day. It's a lot of page views. We had all hands on deck during the day to make sure we had the proper capacity in place, that we were closing orders, that our backends were working well. We found out last minute problems with some systems, and then we were able to fix it. By 12 a.m. from 26 to the 27, we saw a huge jump on traffic. Everything scaled up. Then everyone went home. We didn't make a Black Friday party. I don't know if outside of Brazil this is common. In Brazil, other e-commerce, they do like Black Friday parties all over the night. So we decided that everyone should get some rest. 5 people stayed at the office. All of them slept on our leisure room or played video game. I kept following monitoring, analytics, and watching Karate Kid. So we were really not worried about our capacity. On November 27, traffic came back ramping up around 6 a.m. Always scale up worked, and that's it. The rest is history. So we were well succeed, and then we took a couple of advice, if I may, that helped us. First, do your analysis in-house and start small. It helped us a lot that the most senior developer for the website, he is very knowledgeable on AWS. So we did a lot of analysis in terms of what we should be changing on our application and what we should be using AWS resources. When you do a Lambda, when you program your Lambda job, we decide to use Python. So we decided to use Python because we are a Python shop, and the native data types for Python are the best. Also, we had many Python libraries that helped us to create more elaborated functions than just counting and blocking IP addresses. Also, we like more the Python runtime on Lambda. Our experience is better with Python than Node.js. Maybe that's because we are more specialized on Python. Think about the time it takes to process logs. So CloudFront batches the log and sends to S3. This takes some time depending on how many access you are getting. So when you apply a rule, think about how long you should be taking this rule until you get another signal that tells you to take out this rule. So if you block an IP address, make sure you're blocking it for a couple of hours and that this is right to block the IP address. So play with your thresholds and play with the time that it takes to process logs. So, and defense in depth, so simple security rules at perimeter, complex security rules closer to the app. We reduced our pool of application servers because we took out responsibility and we took a layered approach to the security and traffic, letting CloudFront take care of our traffic, helped us to scale properly and not worry about this blocking and allowing IP address rules there. So each layer that we had, CloudFront, WAF, ELB, and our servers internally have Nginx and a Python application. They have specific responsibility. At our server, we have an Nginx application that we put a very simple rule to throttle specific requests. We would not be able to treat that at scale. You would not be able to take out intelligence from it at scale. So we pick and choose the right rules in the right place. I think that's it. I'm getting back to Nicole. And if you guys have any questions, I'll be happy to answer.
Hey, thanks, Lycon. And as promised, we have a number of the tutorials. All the tutorials for the protections you see today are going to be available on the WAF document site at the link at the bottom of the screen there. Two of the protections you've seen have already been blogged about on the AWS security blog, so if you want more details, feel free to check out the blog. And stay tuned to the security blog for the two upcoming blog notifications for the bad bot protection you saw today and the IP reputation list import tool.
And thank you to both Nathan and Glaycon for that presentation. And thanks to our audience today for submitting some great questions. We've been able to address quite a few via the Q&A pod, but we apologize in advance if we might not have been able to answer everyone's questions. We do have a log of all the questions from today's webinar, and the team will work hard to respond to all of you in a timely manner. If you didn't see a response today during the presentation or a response in the next few days via email, please post your question on the AWS WAF form so we can get an answer to you. And so that will conclude our webinar on using AWS WAF and Lambda for automatic protection. Thank you all for taking time out of your day to learn more about AWS services. And I'd like to extend a special thank you to our presenters, Nathan and Glaycon, for their time and sharing today's content with you. If you have any comments on our previous or upcoming webinars or suggestions on the topics you wish AWS may cover in future webinars, please feel free to email aws-webcasts@amazon.com. As always, your feedback helps improve our webinar programming. Thank you.